Thank you for coming to Data to Drive Decision Making. Everyone, ladies and gentlemen, please welcome to the stage Mike Ambinder from Valve.
Thank you very much. Thanks for coming to my talk. Much appreciated. My name is Mike Ambinder. I'm an experimental psychologist at Valve, and going to talk to you guys today about how we use data to drive the choices and decisions that we make. It's just an approach that we've kind of developed over the years in terms of trying to make accurate decisions. And I'm going to walk you through kind of our process for making choices, and then go through a few examples of kind of how we've, just how we use this approach in practice. So just a quick overview of the talk. I'll give you guys some background on decision-making at Valve, walk you through an intro to experimental design, give you some background on our collection and analysis infrastructure, and then go through 3 specific examples, playtesting on Left 4 Dead, and something from Dota, and something from Counter-Strike. I said I'm an experimental psychologist. I am not a clinical psychologist. If I was, this is perhaps what I would be doing. Having therapy sessions with people at Valve and offering interpretations of mental state. But as an experimental psychologist, my job is basically it's to apply knowledge and methodologies from psychology to game design. So you could think about how to foster cooperation or competition among players, how to manipulate visual attention, designing experiments for in-game economies, all kinds of things. I do a lot of data analysis. Obviously, this is the point of the talk. But it's basically just taking what we know about human behavior and applying it to game design. So decision-making at Valve. This is an example of one decision you could make at Valve, picking a hero in Dota. I recommend Legion Commander. She's awesome. But yes, we'll go through kind of other choices you can also make. One reason that decision-making is so important here, and not that it's not important anywhere, but we don't have a centralized command hierarchy. We have no formal management structure. Everyone is kind of responsible for making their own decisions and kind of given the freedom and responsibility to do so. As such, decision-making is a meritocracy. Like the best decisions will win out. And I guess I'm kind of going to skip to the 4th bullet point, is we just want to make the best decisions possible. That's all we're after. We don't want any barriers in the way to making the best decisions we can, whether it's managerial, financial, if we're lucky, and so forth. So all we're after is making as good a decision as we possibly can. And so one key component of that is that all data we have is available to every employee. If you're a full-time employee at Valve, you can know to the cent how much money Team Fortress made in the last month, or last year, or in its lifetime. You can know how many in-game items we sold in Dota. You can know how games are selling on Steam. We want, if you have a choice or decision you have to make, we want you to have the data available to make that decision. The only thing that's kept quiet is employee compensation, and as you can speak, we can speak afterwards. That's why that's probably a good idea. But everything else, we want all data available to every employee. So if you want to make a decision and there's data that you need, you can go get it. There are no barriers to that. The last point I want to make is that when we're using data to drive decision making, is we don't want to rely on instinct. I'm a psychologist up here. I'm happy to talk to you guys afterwards about all the ways in which our intuition fails us. There are lots of biases that come into play, lots of ways that we interpret data and integrate information, and we fail all the time. And we think we're really good at it, and lots of the time we are, but we fail all the time. And so we'd much rather base our decisions on available data as opposed to following our instinct or our gut. Not that our instincts or our guts are wrong, but we can improve their kind of decision-making ability if we actually have data to back up what we think is true. This is a diagram taken from our employee handbook, just kind of showing, again, emphasizing the lack of hierarchy at Valve. And the only reason I have it here is, again, to emphasize the point that because we don't have, a hierarchy of decision-making where, different people are making decisions at different levels, it really is incumbent upon every employee at Valve to think long and hard about the choices they're making and to make the best decisions possible. So we spend an awful lot of time trying to figure out how to make good decisions and what's the best possible way to do that. So let's get into one framework we have for decision making, or how you would evaluate decisions. I've chosen 5 terms here. There are others you could use. This is not rocket science, but it's a useful framework to have in terms of when thinking about the choices you're making and the decisions, I guess that affect kind of the products and services that you make. So the 5 terms being explicit, being data-driven, being theory-driven, having measurable outcomes, and having an iterative approach to decision making. And now I'll walk through what I mean by each of those terms. So for explicit, what I'm after is, what problem are you trying to solve? be very explicit about the terminology, the constructs, and the problem space that you're defining. Like, be very clear. So we want to make Dota a better game. What does that mean? When I say ask the second question, I mean walk through that process. We want to make Dota a better game. No. What do you mean by that? We want to make the community, happier. What do you mean by that? We want to make the community nicer to one another. We want them to be more productive, have more positive interactions. We want to reduce negative outcomes. Be very explicit. Keep asking questions. My favorite question to ask, the second question I always ask, is what do you mean by that? Whenever someone has an assertion about something, when they're saying, hey, we should do this, well, why would you do that? Like, try and understand why people think something is the case, and ask that second question. Get more information. Figure out what's going on. And then the last 2 points is, when you're doing this for yourself, is force yourself to be specific and make sure you're precise. Make sure you're not being hand-wavy or nebulous. Make sure you're actually defining a problem and saying, hey, this is exactly what I want to solve, and this is why I want to solve it. Being data-driven, this is how we make smart decisions. What do we already know about the problem? What data is already out there that will help us, get to a point, get to a solution quicker? What do we know? And conversely, what do we need to know before we decide? What data do we not have? What data should we go and collect? What's missing? We want to make the best decisions possible, and we're making decisions under uncertainty, and we're never going to be optimal. But we want to know, what we know. We want to know what we don't know, so we can make better decisions. And then, after you make a choice, what do we still not know? It's not controversial to say that it's unlikely that we'll ever perfectly solve any problem we decide to tackle. But we can get close, and we can get really close. But there's always going to be things we don't know, and being honest with ourselves about what we don't know can be as important as being honest with ourselves about what you actually do know. The third point is being theory-driven. So we have data, we have results, we have evidence of something. But what does the data actually mean? Is it consistent with our expectations? If it is, why? If it's not, why? Is it reliable? If I look at sales patterns during a Steam sale, and then I look at customer behavior outside of a Steam sale, is it going to be the same? Likely not, right? So, this is an obvious difference, right? But it makes the point that you have to be kind of aware of where your data is coming from and how likely is it to be repeated. There are lots of things that could be affecting behavior and customers and what people are thinking at any point in time, and so you want to know how reliable your data actually is. This is why, and again, if we talk about statistics, we talk about kind of sampling over and over and having more confidence in your data. But going back to the theory-based stuff, what you want is a model derived from prior experience or analysis, right? You want to have some intuition about why things are the way they are. You want to have some explanation for what's going on. You want to have a coherent narrative, right? Like, this is the outcome we found because of this. Having more heroes in Dota is a good thing. Why is that the case? Is it the case? It's an open question. We don't know, but we'd like to have a theory that would explain that or point us in the right direction. The goal with any decision we make is we want to prove a hypothesis right or wrong. We want to have some explanation for what's going on. We want a result and an explanation. Steam sales are great. People spend more money, they buy more products when the price is discounted. Okay, so that's a result. Why is that the case? It can be a very straightforward explanation, a very simple explanation. That's fine. But we still want to know why. Because when you know why, then you can start building up a database of knowledge, a storehouse of knowledge, and you can make smarter decisions in the future. You want to know why. So make sure when you're making a choice, when you have a decision to make, when you're tackling a problem, you don't stop at just getting the result. You keep looking for an explanation as well. So measurable outcomes. I'm not going to say this is the most important part of every choice we make, but it's a pretty important, well, as these all are, it's a pretty useful one. With every choice you make, with every problem you're trying to solve, with every decision you make, know what success is. We want to make Dota better. We want to sell more copies of TF2. We want, well, to make Dota better was not a good example, but we want to, sell more items in our in-game economies. We want people to play more games of Dota. We want people to be nicer in TF2. We want more partners to come onto Steam. Know what success is. You need to know with every choice you made, how you made the right choice. Have you made the right choice? If you don't have an outcome of your decision, if your decision is loosely tied to something that is not measurable, then how do you know it was a good one? The way you know if your choices, the way you know the choices you made are good is you have a measurable outcome. And you can say, hey, this is success. If this number goes up, this is a positive result. If this number goes down, this is a negative result. You need to operationalize your decisions. You need to make sure that you have some way of measuring success. Otherwise, you're kind of just, again, going back to instinct, which is fine, but likely to lead you to suboptimal decisions in the long run. What you want is a way of measuring the outcome of your choices. So something we always think about. With every choice we make, we're like, well, how are we measuring success? We're making a change to the game, or we're doing something, we're adding a feature to Steam. How do we measure success, right? And again, it can be really straightforward and basic. We're looking at usage patterns of a Steam feature, right? Are people going to use the new Steam Groups feature? Okay, well, we want to measure that. We want to know if they are or not. We don't want to just say, hey, having Steam Groups is a good idea. Maybe it's not. Last point I want to make is being iterative. And this is something, it's just the notion that we're not operating in a vacuum. Every decision we make is not in isolation. What happens is we, have a theory about what's going on. We gather data to, either disprove or prove that hypothesis. We analyze the data, and then we get to make a new hypothesis. We get to use the data, from one decision, from one choice we made, and then use it in every other choice we make. Another way to think about this, and that's where we think about this, is experiments in TF2 inform experiments in Dota, which inform experiments in Counter-Strike, and vice versa. And all of these can affect Steam, and the Steam arrow should probably be bidirectional too, but I forgot to do that. But the point being is that we often think about running experiments in one game. Like we've referred to TF2 as a test bed for Dota, and vice versa. Experiments in one place will inform experiments in another. We want to build up, again, I'm going to use this phrase a few more times in the talk probably, like a knowledge base, right? A storehouse of information about why our customers do the things that they do. And so, we don't operate in a vacuum, and every choice we make can impact other, every choice we make in one product can impact the choices we make in other products and services. And so we're constantly thinking about how things we do in Dota might affect TF2 and vice versa. So moving on to the next topic, this is a great quote by Sagan. If it can be destroyed by the truth, it deserves to be destroyed by the truth. We don't want to believe what we want to believe. We want to believe what actually is, if that makes sense. We don't want that. We all have notions about what we think is the case. We all want to be right all the time. I want to be right. Everyone wants to be right. We'd rather be accurate than right, if that makes sense. What we want is the truth. We want estimations. We want our estimations of how reality is to match how reality actually is. We don't want to believe what we want to believe. We want to know what is actually the case, what is actually going on. So the point being is that, if we think we made the right choice with something, some feature we added, something we did, if data comes along and says, hey, you made the wrong mistake, the wrong choice, we need to acknowledge that we made a mistake and move onward. So we're perfectly willing to accept that we made mistakes. We probably make hundreds, if not thousands, of mistakes every day. There's too much going on to be accurate or completely right all the time. And so we're just after the truth. We want to know what's going on. Why are our customers doing this? How can we make them happier? And if our intuitions about something they're doing is wrong, we want that to be corrected. So this is the scientific method. This is a graph that you guys all probably saw in second grade. And it's just, this is how people have been creating knowledge, for probably thousands of years. You start with an observation. Can use I don't think the pointer is very bright, so we'll just have you guys, follow along. But you start with an observation, right? You take what you know about the world, and you use that information to develop a hypothesis, a theory about how the world is actually working. When you have a hypothesis about how the world actually works, you make a prediction. And then when you have a prediction, say, hey, adding trading to an in-game economy is a good idea. Then you can run an experiment. You can put trading in an in-game economy and put it in TF2 and see what happens. You gather data, see if it's a good thing or not. And then you have a new database. You have a new observation. You have a new way of looking at the world. And you can make further theories and further predictions and further experiments, right? It's a cycle. It's iterative. This is the process that we apply. This is the process that basically everybody applies. And it's how we create knowledge. It's how we make informed decisions. And again, it's as far as we can tell, it's the best way we have to kind of get to a place where we can be confident in the choices that we're making. One point I do want to make fairly quickly is, so we all work at game companies, right? We all operate under constraints, and it can be tough sometimes to actually identify the root causes of problems. So there's two kinds of, for lack of a better term, studies that you can run. One is observational, so this is looking at historical data. So for example, we're looking at, we see sales rising when there's a discounted price on Steam. That's looking at historical data. We can be prospective. We can look to the future. We think that sales will rise if we have a sale on Steam. This is correlational. It's highly correlational, but it's not causal because we didn't run the actual experiment. We didn't say, hey, let's have a control condition. Let's have a baseline where a certain percentage of customers didn't get the sale, and a certain percentage do, and then watch what happens. We've actually, there's probably a lot of data that says that Steam sales are a good thing. We definitely believe they are. But the notion that something is correlational and not causal is an important, I guess, factor to take into account. When we were running, doing experiments in the TF store on the interface, what we could have done was change the store interface and seen an increase in sales, and that would have been fantastic. That would have been correlational data. There's a relationship there, but we didn't actually identify a cause. To identify a cause, what we should have done, and what we actually did, is say, hey, half the people will get the new store, half the people will get the old store. If sales go up with the new store and not in the old store, the only difference between them, the variable of interest, is the interface. Hey, the store is successful. So when you actually run experiments that have a control on an experimental condition, what you're doing is trying to eliminate the influence. Well, you're trying to eliminate external influences. We call them confounds or confounding variables. But the point being is that you want to be as clear as you can. You want to, I guess, do as good a job as you can to eliminate all possible external influences from the data you're collecting from the experiment you're running. So this is just kind of another example that makes the correlational causal distinction. You can see on the bottom, the x-axis, you can see the number of pirates in the world. It's decreasing over time, or roughly decreasing. Average temperature of the world is increasing over time. This is the correlation. It's highly significant. It's probably not causal. The number of pirates in the world is probably not related to the average temperature of the Earth. Maybe it is, but we don't actually know because we didn't run the experiment to say, hey, okay, we have a world with pirates and a world without. What happens? Okay, so when you're done with an experiment, so you've gathered data, you've looked at things. Something else to keep in mind is, what do we take away from this experiment? What have we learned? And be honest with yourself. Like that's a theme that'll run through this talk. Is like make sure you're always being honest. Like what have we learned? What biases are present? Right? Bias doesn't have to be a bad word. You just need to know what other factors are impacting your decision. If we release a new content update to Dota the same time as we add more server capacity, and so more people can play, well, maybe people are playing because of the server capacity. Maybe they're playing because of the content update. We don't actually know. We couldn't actually tease that apart. So you need to know what biases are present. You also want to think about, again, this is being iterative, how do you inform future experiments? How does the data you've just collected let you kind of drive forward, impact future decisions you're going to make? And how confident can you be in the results of whatever data you've collected, whatever choice you've made, whatever decision you've made? What other hypotheses need to be ruled out? What else is missing? And how confident are you? Are you 90% confident? Do you want to be 95? How do you get there? And so one thing we're always thinking about is, okay, based off of whatever choice we made, whatever decision we've made, what should we do next? What happens next? What do we now know that we didn't know? And can we make better decisions because of it? Okay, so moving on to the next part of the talk, give you guys just a quick overview of kind of our data collection and analysis infrastructure. Here's our philosophy. The first point, well, I guess the first 2 points. Record lots and lots and lots of user behavior. We record tons of things. We record almost everything that we can, within reason, of course. And if we're not recording it, we'll start recording it. We're always happy to take engineering time to say, hey, what data do we need to answer this question? We don't like answering questions in a vacuum. We don't like answering questions blindly. We'd rather say, hey, do we have the data we need to answer this question? If we don't, let's spend the time to record it. It's not something we ever really regret. We're always happy to take the time to go gather the data. And then, I don't know, the value of gathering data cannot be understated. This is a biased presentation, happy to admit it, but we never, I guess, once run into a problem where the choice to go spend the time to gather data about customer behavior led us to poor decisions or led us to make poorer products. We're always smarter. Doesn't mean we're always right, but we're always smarter when we have the data to back up our intuitions or our hypotheses or our beliefs about what we should be doing. Another point to make, and this is just kind of a more technical point, but and we ran into this problem, so this is why I have it in the talk, is when you're deciding how to store your data and you have a database schema, it's a useful exercise just to run through the questions you want to ask of the data first. You could say, hey, let's record everything, and that's fine. If you don't have some idea of the kinds of questions you want to ask, you run into you can run into efficiency problems in terms of saying, hey, we want to look at the experience of Dota players in their first 10 matches, want to know what games they played, and want to compare that to the people who quit after 5 games, right? Like, come up with sample questions, right? And that will inform your database design and help you, it'll help you answer questions more efficiently. And so it's a useful exercise to run through is say, hey, here's the data we want to collect. How should we organize it? Because these are the kinds of questions we want to ask. And of course, you won't be entirely accurate with the questions you ask, and things will change over time. But it ends up being just something that will save you a lot of time in the long run. Only other point I want to make here is that collecting the data is only the first step, right? Once you have the data, you have to spend some time on analysis, and then figure out how to communicate that. What's the best methodology, the best way to get that out to other people, right? So collection is step 1 of a 3-step process, and possibly longer. But the point is that once you have the data, you need to make sure you have an idea of how you're going to make use of it, and then how you're going to share what you found with other people who need to see it, who could take advantage of it. So for us, we have a system called OGS. I think it stands for Operational Game Stats, but I'm not sure. Feel free to create your own acronym. SQL database is a platform for recording gameplay metrics. We record everything. Everything goes into OGS. Kills, deaths, your hero choices, how long you've been matchmaking. For Counter-Strike, at one point, I think we stopped doing this because it was actually too much. We recorded every bullet fired in Counter-Strike, every bullet, so where you were standing, what you hit, the accuracy, the angle. Just we weren't sure. Maybe we'd make use of it. I think we don't sample every bullet, but we have a high enough sample to still do some stuff with it. The point being that if we think there's something useful that we'd like to collect about what our players are doing in game, then we'll go ahead and do that. So again, just in terms of technical details, we have organizational schemas that are defined for each game. What you store in Left 4 Dead is different from what you store in Portal, is different from what you store in Dota, and so forth. And we send the data at relevant intervals. So in Dota, you might send some matchmaking data as soon as a match is formed, and then you'll send a bunch of game data after the game ends. And we also sample game state. So every 5 minutes, we have an understanding of what's happening in Dota. So we can actually use that to build pretty cool predictive models about who's going to win and whatnot. We also have every kind of aggregation you could possibly want, daily, monthly, lifetime, combinations of things, and then futuristic stuff that people who are much better at SQL than I am can write and kind of parse the data. The way we kind of disseminate the data is we use this is a visualization tool called Tableau. Valve Stats is just our internal name for the website. But we have all kinds of just visualizations of the data we've collected. I don't know if you guys can read those, but there's account, the first purchase made on an account. There's performance for Chinese users. There's hero stuff. There's item balance, item purchases, geographic purchases, and so forth. I think I took a look at it. We have about 200 separate workbooks across all Valve games and about 800 individual pieces of analysis, and that's growing every week. And anybody at Valve, any full-time employee at Valve can go here and look at anything they want. And if there's something they want that's not there, then we have the infrastructure in place to go collect it and then publish it to everybody. The same philosophy that we apply to our games applies to Steam. We have Steam database, which has all of our raw data. I believe everybody in here has either published a game on Steam or is about to, so you guys are probably all familiar with Steam stats. Same thing we use. And the goals are the same, right? We want to know what people are doing on Steam. We want to have data to help us answer the questions that are of interest to us and to our customers and to our partners. And I know the text is kind of hard to read, but this is just an example again. I think we have, I didn't do count, probably tens of thousands of Steam stats pages, information on every game, right? How many purchasers, how many users, what their peak and current is, the average revenue per user, average revenue per paying user. I'm happy to discuss offline with you guys whether or not ARPU and ARPU are good metrics to use. We can have that discussion later. But yeah, the point being that, again, this data is accessible to every Valve employee. And people can use it to go out and answer the questions they think are interesting. So playtesting. This is an old picture of me from 5 years ago. I think I'm pretending to be a scientist, pouring Gatorade into a cup. And then you can see the playtester satisfaction index in the background. So we're getting into the examples part of the talk. But before I kind of jump into that, I wanted to make a point about our game design process and how it's as data-driven as everything else we do. To the extent that you like Valve games and want to know how we make games, this is it. The goal is a game that makes customers happy, right? Like, this is what we all have, same goal we all have. We want to make a good game. We want to make a game that customers want to play, they want to buy, they want to consume, they want their friends to enjoy, and so forth. Every game design we have is just a hypothesis. Like, that's it. Like, that's the way we view it. The game designs we have are hypotheses, right? And the playtests are our experiments. We are very poor proxies for our customers. We're happy to admit it. We cannot look at things with an unbiased eye. That's fine. We have lots of people who are amazing game designers, right? But we don't know if something actually works until we put it in front of people who are not us. So we run lots of playtests. We run them as early and as often as we can. If you're running a playtest only at the end of your game development cycle, it's probably too late. That third line is the reason why TF2 took 8 years to make, in case you're curious. We had thoughts about how TF2 would work. We ran playtests. It did not meet our expectations, so we went back to the drawing board. Our customers were right, we were wrong. We learned that. We evaluate our designs based off of the playtest results and repeat the process. This is how we make games. You have to remove a little bit of ego from the process, but the point is that we have a game design. We don't know if it's a good one or not until we put it in front of people who are not us. So we run playtests all the time with as many people as we can just to gather data, right? And so it's just the same process I was describing before. It's the scientific method, right? We have hypotheses, we test them, and then we iterate and improve based off of the data we gather. And I like that point so much, I'm just doing it in more visual form. But you can see on the left, we start with content creation, game design, which leads to a hypothesis about what players will enjoy. We do playtesting, we gather that feedback, and put that right back into the process of the content creation and game design, being iterative. I guess one final point about playtest is that, or playtesting anyway, is that when you're gathering data from people, there are a variety of means that you can use to grab information from folks. The more traditional methods are direct observation, just watching somebody play the game, verbal reports, so this is having people think aloud or talk aloud while they're playing the game. I'm not a fan of that methodology just because what happens is you end up forcing people to play the game in an artificial manner and not in a more naturalistic fashion, more akin to what they would be doing if they were playing the game at home. But it has some utility. And then Q&As. And then there is the technical side of things, which is playing around with stats and data analysis, doing specific design experiments, surveys, and even some of the more esoteric stuff like measuring heart rate or using eye tracking or so forth. The point of these two slides is just something to keep in mind is that different methodologies are best suited to answer various kinds of questions. For example, surveys, fantastic for quantifying preference, like rank order your choices for the weapons. Your rank order the weapons in Counter-Strike. Let us know what you liked. Or for forcing choice. Eye tracking is great for getting an index of visual attention. Where are people looking in the game in real time while they're playing? Direct observation is fantastic for just about everything. So that's what we all kind of rely on. But it's just important to think about, and it's a key point, is that there are ways to gather the data that you're trying to go after. And so especially in playtesting, trying to be aware of the pros and cons of each of these kind of methodologies is important when you're saying, hey, what kind of problem am I trying to answer? What's the best methodology suited to answer that question? OK, so we'll walk you guys through just a few quick examples. Left 4 Dead is a game that came out, I think, 5 years ago, or 5.5 years ago. It's a zombie apocalypse survival game. You have teams of 4 players, and it's a cooperative game. It's a game where competing will get you killed. If you're not playing with your teammates, you will die. There are monsters that can drag you away. You need to work together to actually survive. When we first started playtesting the game, people liked it. They really liked it. But the initial playtests were not as enjoyable as we hoped, and players were not as cooperative as we hoped. And we didn't know why. We were like, hey, this is a cooperative game. It's We thought we had designed it to be cooperative. What was going on? What we noticed was that players were letting their teammates die, which is not a good thing. You want your teammates to live. And they were also ignoring cries for help. So people this is a game that usually people play with microphones, and everybody in our playtest had microphones. But players were actually ignoring cries for help. We wanted to know why that was. So if you think about us trying to make a decision, solve a problem, and applying that framework we described earlier, the explicit issue we're after or trying to solve is why were players letting teammates die? The data we had to suggest this was obviously, of course, high death rates in the game. Anecdotal reports from Q&As that said, hey, my friends aren't being cooperative. I didn't know where they were. We had surveys that kind of said people weren't being cooperative and whatnot. We actually asked people if they knew where their teammates were, and in the Q&As they would say yes. Most of them would say yes, but not often. But we kind of actually thought, hey, okay, we know that there's something going on. We know that people are not rescuing their teammates. We know that is kind of a key indication of cooperation. And our theory, our hypothesis, was that it was actually due to people not knowing where their teammates were. That whatever, our game designs we had were not good enough. That people just did not know that their teammates were in trouble, even though they were getting verbal cues to such, that people were in trouble. We kind of just, it seemed clear to us that something weird was going on. We wanted to take a stab at it. So our theory was that people lacked awareness of the teammate location. And we're happy to use, so we're going to make a change to the game and try and increase awareness of teammate location. We can use the same measurements, trying to measure success here. We can measure cooperation in the surveys. We can do Q&As and see if people change their responses, and we can look at death rates and see if death rates go down. We weren't actually sure how this would be iterative. This is information that we weren't sure what the outcome of the experiment was going to be. We weren't actually sure. And again, this is just kind of an illustrative point, that you won't always have an answer to all of these questions. And you won't always know how things are going to impact other things down the line, but it's always just, it's useful to keep in mind, okay, hey, how could this impact things that are working or going to happen down the line? So our hypothesis was that if you give better visual cues to teammate location, teammates will find each other, they will save them, people will be more cooperative, and people will like the game better. So this is how Left 4 Dead used to look. Bill is a character name, if you can see that in the center of the screen. And so this is how the game would look to you if your teammate was in trouble originally. This is how it looked after the playtest, after we made a change, after we added visual cues. The orange outline figure is your teammate. The figure outlined in red is a hunter, one of the special kind of boss monsters we have in the game. It's attacking your teammate. Your teammate will die if you don't go save him. So it used to be this. Now it looks like this. As soon as we made that change, so as soon as people had the visual cue, and remember, they're still getting verbal cues, like their teammates yelling, I'm stuck, I'm getting attacked, whatever, deaths go down by 40%, which seemed to us like a pretty good change. We were happy with that. And so we also, our ratings of enjoyment and cooperation increased. The anecdotal responses of people saying, hey, my teammates are bad teammates, those decreased, and deaths decreased. So it ended up being a successful change for us. And then going back to that, kind of the framework, now we have kind of another tool in the toolbox, right? When behavior is unclear to us, and we're not sure what's going on, and things are kind of, people are saying that they know where their teammates are, but their behavior is not matching it. Well, now we can think about, okay, we have this experience where they didn't have effective visual cues. They couldn't articulate that to us, but now we know that could be a possible explanation for behavior, so we can use that going forward. And again, this is, I'm not trying to postulate this is anything like fancy or crazy or anything incredibly intelligent. It's just kind of a way of saying, hey, here's a problem we had to try and solve. Now we have data that suggests that, hey, we solved it effectively, so we can use that information to solve other problems. So the whole point of being iterative. Okay, so moving on to another example. How many of you have played Dota? Okay, fair amount. So one thing you may have noticed about Dota is that people are incredibly polite in the game. Like, fantastic, always helpful, wonderful people, the cream of the crop. So here's an example, piece of Dota chat. I'll let you guys read that. Okay, so yeah, this is, for those of you unfamiliar with Dota, this is typically how chat goes. People are very helpful. They love helping new players. If somebody dies, not a problem. Everybody's cool with it. That's all good. So just to set the groundwork. However, in the case, for cases where players are perhaps less than cordial to their teammates and to other players in game, it might be a goal we have, and it was a goal we had, was to reduce, negative communication occurrences in game, like people either over, in text chat or over voice being less than cordial to one another. We had a lot of data to suggest that this was an issue. You can look at, kind of chat logs. We have a reporting system in game where you can let us know that somebody was being mean or whatnot. People were complaining in forums. We get emails about it, and people could actually, quit the game because they had bad experiences. So you could look at, the chat logs and see, okay, hey, somebody had a negative experience and they actually ended up leaving the game. The only actually, I think, significant predictor we ever found for why someone would quit Dota early on was having being in a game where someone else got reported for abusive behavior. Like nothing else mattered, like what heroes they played, what game modes they played, and so forth. That doesn't mean that problem is solved or that question is answered. We can do more with it, but it was just, we definitely had data to suggest that it was an issue. Our theory behind it was that we had no feedback loop to punish negativity. There were no consequences to behavior. People could, do what they wanted. Again, the very small percentage that could be a little more aggressive. And so there was no way to kind of tie action to outcome. They had no way of learning that what they were doing was wrong. And you actually could, if you go and you'd read forum posts and say, hey, people would actually post a text that they wrote that other people responded negatively to, and they didn't think they did anything wrong. Like they were like, oh, like this is, I was, my teammate messed up, I was letting him know, and this is perfectly normal. Like people did not understand how they were coming across to others. So our theory was that, okay, we had no feedback loop. We need to add some kind of feedback loop to punish negativity. So you could reward positive behavior, which is another axis. In this case, we chose to kind of disincentivize negative behavior. But the point being is that we wanted to have some sort of feedback loop. And so, okay, well, how do you measure negativity in a game? You can look at chat. We can look at, people can, our report counts in game. If we do have, a punishment, what are the ban rates? And then how often do people get punished? Are they being punished a lot? Is it having an impact? If it is, then people should get one punishment and stop. If it's not having an impact, then people should get lots of punishments and not really care. In terms of being iterative, we think, we weren't sure. This was kind of one of the first automated systems we had. So again, applying that, if you remember back to a few slides ago, we think about how it would work in other games, what would work in TF, what would work in Counter-Strike, and how well does an automated system, does a system that kind of punishes folks in this fashion, and I'll describe the system in a second, how well do these systems scale? We have millions of people playing Dota. There's 40 people on the Dota team. So how well does a system like this scale as we add more people to the ecosystem? And what are the problems that arise when you kind of end up implementing, as we did, an automated system? So our hypothesis was basically that if we had an automated system that prevented people from chatting in game for periods of time, that we would actually reduce negativity overall in the game. And just to kind of walk you guys through the way it works, on the left side you can see report dialogue. You can choose whether someone was, being, was, I guess, abusing, communication. The other two options are whether or not they were spamming their abilities or they were feeding, just intentionally dying. And the text there, it says using offensive language. So every player in the game gets a certain number of reports per week. And if players get a certain number of communication reports in a week, what happens is we take away their ability to chat and communicate via voice for a day or 2 days or a week, depending on the severity of the offense and how many times they've been banned. On the right is the other important part of the system, which is feedback for the player who reports somebody who is being negative in game. So there's a feedback loop for the player who's abusing things, who's being abusive. And there's a feedback loop for the person reporting the player. And this is important too. As humans, we like to feel like our actions have consequences, right? We like to feel that we have control over certain aspects of our environment. And so this is one way of letting people know, hey, if somebody in your game was abusive, you actually had a measurable impact, like you actually had an outcome that resulted in them not being able to chat for a while, right? You had an impact. Your influence caused a particular outcome for this player that will make the overall experience of everybody in the community better. So it's an important piece, right? So there's feedback for both the abusers and then the people who are reporting the abusers. So here are the results. 35% fewer negative words used in chat. It was not a pleasant experience having to type or generate that word list. I did not enjoy that, but the results were good. A bunch fewer communication reports in game. Only 1% of our active player base is currently banned. That number fluctuates a little bit, but it hovers around 1%. You could make an argument that that's too low. That maybe we should actually have stricter criteria that ban more players or prevent more players from using communication. But the point being is that we had a system that was automated and it scaled well. We didn't end up running into problems where large swaths of people were getting banned and having a different kind of negative impact on the game. And then not the most important point, but again maybe the most important point, of players who got banned in the system, 61% only received one ban. So we had 39% were repeat offenders, 61% one ban, and they were good. So all of a sudden we reduced, again, I mean, this number can fluctuate and things can change, but after this was, I think we collected this data a month and a half, 2 months after we released the system. 61% of players needed one lesson, one ban, and they became better. They stopped being reported, which we saw as kind of very happy. We were very happy with those results. That saying, okay, now we've educated the player base, and the hope is that now that players are getting banned, that we can. People will learn that there are certain kinds of behavior that is not tolerated in the community, and the players who were banned once and then stop being banned can serve as they can serve as exemplars for the people who were banned multiple times. So our final example, and then we can kind of get on to questions. This is a graph, and I know it's a little bit hard to see. All I want you guys to focus on is the green part of the graph. So this is so on the bottom, the x-axis is just the amount of money you have increasing from left to right at the start of a round in Counter-Strike. The y-axis is just kind of a percentage of total purchases of what weapon you bought. So you can see that the M4A4, once you get past, once you at $4,000 onward, basically you're buying the M4A4. That's the choice you're making in Counter-Strike. This is data sampled across all users in Counter-Strike. So people love the M4A4. Fantastic, great. They love the weapon. That's fine. We weren't sure that was a good thing. That people were, that such a high percentage of users, once you got to $4,000, that's all you cared about. That's all you bought. It could be a good thing. People like Counter-Strike, but we weren't sure. So the problem we're trying to solve, the decision we're after, right, is can we make, can we add balance to the game? We know the M4A4 usage is high. We know you have a few choices in the late game. What happens when we add more? Can we add more? Should we add more? This is the question. Again, the data we had was the purchase rates I just showed you. The theory behind it, and this should kind of is derived from experience developing other games. Counter-Strike may be its own beast, but even in Counter-Strike, the notion of greater tactical choice likely leads to increased player retention. If players have more opportunity to demonstrate skill, it's likely they will end up playing the game longer. This is a thesis that it can be applied to Dota and applied to most games, and it makes sense to us that if you give players more tactical choices, they will end up enjoying the game and playing the game longer because you have a wider variety of experience. How can we measure this? Well, we look at the same, if we design a new weapon that adds tactical choice, that's fantastic. We can look at purchase rates. We can look and see if players play more. Or we can look at the efficacy of the weapon and how that affects other things, like if it's more accurate, if people win more matches, like how does what other factors are going into that. And then being iterative, of course, is we're going to inform future design choices. We want to know how tactical choice in Counter-Strike affects how people play and consume the game. Is the impact positive or negative? What's going to happen? So our hypothesis was that creating a balanced alternative weapon will increase player choice and increase play time. So the weapon we created was a silenced M4A1. It was more accurate. It cost a little bit less, but had a smaller magazine. But we felt like the overall trade-off was the same. So this is what happened after we introduced the silenced M4A1. They are the light orange bars on the graph. And you can see, if you remember the first graph, the light green is the M4A4, and now you can see light green is still M4A4, and the light orange is the new weapon, the silenced M4A1. So it's about, we introduced a new weapon, and this is a pretty salient effect, right? Like across all levels, all of a sudden, instead of going from, a weapon that was 75% of all possible choices, you have two, in that 75% of the total, you have two choices evenly split. So in theory, that's a success, right? Seems like one. So we saw, a roughly 50-50 split between the new and the old favorites. The new is the silenced weapon, the old is the M4A4. We did see an increase in playtime. The reason I don't have a graph for you, or I'm not showing you a graph, is because we're not sure if that's actually, because of the silenced, the introduction of the silenced weapon, the new weapon. We introduced the new weapon at the same time we added other content to Counter-Strike. It was around the time we added the economy and some other game modes. So the increase in playtime could have nothing to do with the introduction of the new weapon. Right? This goes back to that notion of what biases are in play and going into the notion of correlational data versus being causal. We didn't know what was actually going on, so I can't tell you that introducing the new weapon was a good thing. We saw an increase in playtime, but we don't know why that was the case. So it's still an open question as to whether or not increased weapon variability in Counter-Strike actually increases player retention. I kind of chose this example last, like by design, just to kind of emphasize the point that, hey, knowledge acquisition and creation and accumulation as a process, we're still working through it. There's a lot there. There's far more we don't know than what that we do, and so we're only at the surface of we're only scratching the surface of what is possible to know about how players and consumers, I guess, play and consume video games. So this is basically the last slide of the talk. Where can you begin? If you're not already, asking questions, trying to use data to drive your decision making, start. What do you not know? What are the most interesting things that you want to know? We have thousands, and not exaggerating, we have thousands of things we want to know. We have thousands more that we're kind of sure of, but we could use more confirmation. Start asking questions and start gathering data. Gather any data. Run more playtests, start implementing gameplay metrics, go to Steam stats and bang through things, and search forum posts, emails, Reddit. I mean, these are all things that people are doing, but it's, we look to all these sources to give us the data we need to make better choices. And then this is the most important data point on the graph, and probably the reason I'm giving the talk, is let us know what data you'd like us to provide. Like, how can we guys help you? How can we help you make better decisions? Like, we'd love to. Like, how can Steam, how can Valve help you guys make better choices? That's all we think about. How can we make better choices? And we'd love to help you guys. So just please, let us know. Tell us how we can help you. Thank you very much. Again, I think for questions, you can just go to the mic. I'll stay as long as you guys want. Happy to answer any questions. If we get kicked out of here, we can just go over there. If not, send me an email. I'll also be around tomorrow, so all day, really, so you can just come find me then. But thank you very much, guys. Much appreciated.
Guys, thank you for joining us. We do just have time for just a question or two, and we do have another session here, and we'll be back in here with a new one at 5 p.m.
So I will head to the central area after this, but yeah.
My question is how often do you do play testing, and what is the sample size of your play tests? And you mentioned you couldn't isolate that one Counter-Strike change. Yeah. You were able to isolate that one change in Left 4 Dead. How often do you get to isolate a single change, especially when a game is being in development?
So well, the honest answer is we play this as much as we can, as often as we can, right? And so that's just given the constraints of what's going on. For Left 4 Dead, if you want actual numbers, we were playtesting twice a week, maybe 10 people each day, 20 people a week for half a year. Or longer. I mean, I guess longer than a year actually, working through that. So it can depend. If you actually have a notion of the size of the problem, you can do some statistical analysis to let you know how many people you actually need to answer a question. But the answer is that it's going to be messy sometimes, right? So we're trying to do the best job we can, and we just want to be aware that hey, the data we're collecting might not be reliable. If we only can run, if we can only playtest 5 people, maybe that data is not representative of the population at large. So as long as you're aware of that, then you can be smart about what's going on down the line.
Can you talk about using your data-driven approach to react to game development missteps? In particular, the pros and cons of this approach in response to this year's Dota 2 Dire Tide event?
Well, so I think actually, if you go to if you went to Robin's talk, I think he talks about that a little bit. But yeah, so we make mistakes all the time. And we're happy to admit it. And the way the company is designed is that's fine. Knowing what goes wrong can be just as important as knowing what goes right. So by no means, we're as far from, but we're incredibly far from perfect. But the notion being that, okay, we had certain assumptions about what was going on with Iterative. We thought our customers would be happy that we're working on all this new content, but what we did not realize was, kind of the expectation we had built up by having, Iterative the previous year. And so, this was us, making a mistake and gathering new data, and now we have more informed hypotheses about how to, engage with holiday events in the future. So, we're happy to admit we messed up, and it's just us, not having the correct data, not making the right choice.